Hi and welcome back to Properties and Structures of Matter, and we're looking at inquiry question 4 on bonding. In previous videos we have looked at our dispersion forces as one of our intermolecular forces and a type of bonding. And today we're looking at hydrogen bonding. So hydrogen bonding is, as the name suggests, an attractive force that happens with hydrogen and other elements nearby, but particularly our fluorine, our oxygen, our nitrogen, and our chlorine, those high electronegative elements there. And you can see here in this diagram here where we have our hydrogen to our fluorine. One is our dipole positive, our negative here, and the hydrogen bonds are what attract it to a fluorine in one of the other molecules, because remember, our intermolecular forces are those forces between one molecule and another, not within the molecule there. So this hydrogen bonding only occurs between molecules in which there is a hydrogen atom covalently bonded to another highly electronegative atom, such as our oxygen, nitrogen, chlorine, or fluorine. So the atoms that they are attracted to are highly electronegative, so they are then strongly attracted electrons in that bond. So what happens here is it does create a partial positive charge on the hydrogen atom, as we can see in the diagram that we've got here, and then it's attracted to the lone pair of electrons on the nitrogen or the oxygen, chlorine, and so forth. Now these forces are actually 10 times stronger than dipole-dipole forces, and dipole-dipole forces are stronger again than our dispersion forces. So while they sound relatively strong, and compared to the other intermolecular forces I suppose they are, but they are only about a tenth of the strength of a covalent bond or an ionic bond, which is the bonding that you have been researching. So looking here, as I've just said, they're much weaker. So because they're much weaker, less energy is required to melt that solid compared to breaking chemical bonds. So remember when I said before about that melting, the melting is not the breaking of the bonds between, say, the hydrogen and the chloride, it's the breaking of the bonds between one molecule and another. So looking at the melting and the boiling point tells you a fair bit about the strength of the intermolecular forces. So the higher the boiling point or the melting point, then the stronger that the forces are in play there. So we've looked at polarity of bonds, but we've also looked at polarity of the molecule. And due to water being a polar molecule, what happens is they happily attract each other to each other. So the positive end of one hydrogen atom associates with the minus or the negative end of another atom. For example, that in this case is the oxygen atom here. And so due to this hydrogen bonding that is present, they have a really high 100 degrees, but contrast that in to the chlorine atom that was minus 19 in the previous video, or bromine that was 59. 100 degrees is relatively high for such a small molecule. So remember again, with those dispersion molecules, the bigger the molecule gets, the higher the boiling point. But in this case, we have 100 degrees as a boiling point for a relatively small molecule here. So you can see in our diagram here, we have got our polar covalent bonds inside the atom. So they're our intramolecular forces. We've got our bonding here. They're our polar covalent bonds. But over here between our bonds, we have then our a hydrogen bond there. So highlight your notes, annotate your notes, and we will discuss these a little bit further in the variety of lessons that we're going to have. See you then.